Okay, so now solving quadratics, it wants us to use the best method. You've now learned multiple ways. You've learned factoring, square roots, or factoring and solving by square roots, and solving by completing the square. You also learned by solving by graphing, but we're going to not do that because our answers might have imaginary solutions and we cannot get those with graphing. So we need to figure out which is the best method and solve by that method. So for me, factoring is the fastest method. The only problem is not everything is factorable. So check to see if it's factorable. Can I think of two terms that multiply to 21, multiply to a negative 21, and add up to negative 4? I can. If I had a negative 7 times a positive 3, that is negative 21. And if I took that negative 7 plus that positive 3, I get the negative 4. So I know my factors are going to be negative 7 and 3. So I can write the left side of my equation as an x minus 7 and an x plus 3. Take those two factors and put them inside. I still have it equaling 0. And then I'm going to go ahead and solve. So I know x is, and I have to say x minus 7 equals 0. So remember, whenever it's grouped with x, it's always the opposite sign. Why does that keep happening? So it's a positive 7 and a negative 3. So the method we chose was factoring. And tells us to explain our reasoning. And I'm just going to say because it can be factored. And that factoring is just the fastest method. Look, we're already done with that problem. All right, so now let's go on to number 10. Well, number 10 is set up already to solve by square roots. I have something being squared on the left side equaling a constant. We're just going to solve this by square roots. So I can start it off by square rooting both sides, and I get x plus 4. When I square root the right side, I get plus or minus square root of 16. So I end up with x plus 4. It's going to equal plus or minus 4, because that's what the square root of 16 is. I subtract 4 to each side. Remember that has to go in front of the plus or minus. So x is going to be a negative 4 plus or minus 4. Now before we left it, when we have a radical after this 4, if we were to have one, we would just leave our answer alone. But in this case, I don't. I have a constant. So I'm going to go ahead and do this. This gives me two answers. Whoops, sorry about that. I get x equals a negative 4 plus 4, and an x equals a negative 4 minus 4. Or you could have separated it out right here and said x plus 4 is going to equal 4, and x plus 4 is going to equal a negative 4. Either way, you're going to get the same answer. I just went ahead and moved the minus 4 over, and so I'm going to get an x is 0, and I get an x is a negative 8. All right? So when we do that, we say, well, we had to say our reasoning and what we used. We did this by square roots. And we did it because it can be written in the form u squared equals d. Something being squared equals a number, okay? All right, let's try number 11 and 12 here. All right, now 11 is not factorable, okay? You can try it out. You can, a fast way to do it is if you were to graph this, does it cross your x-axis at perfect numbers, real numbers where it's 1, 2, no decimals, no fractions. If it doesn't even touch the axis, it's imaginary, so we've got to do completing the square. But we're going to do this by, since it's not factorable, and I can't go ahead and do it by square roots because it's not in the form u squared equals d, I'm going to have to do this by completing the square. That's the only other method that I know at this point. So whenever you have a coefficient in front of x squared that is not 1, you have to divide everything by that number. So my equation becomes x squared plus 2x minus 3/2 equals 0. Okay? And it's okay. I see I have a fraction. Fractions don't hurt me. They're numbers. All right, I'm going to add 3/2 to both sides. So I get x squared plus 2x plus some number, my perfect squared trinomial thing that I'm going to try to find, is going to equal now a positive 3/2 because I had to add it to both sides plus that number. So we find the number by taking b, we half it, we square it, we add it to both sides. So 2 being halved is 1, squaring it is 1. So I'm adding 1 to both sides. So my left side becomes x plus 1 squared because you half the b. That's where that 1 comes from. It's not this one. They're different. Well, they're technically the same number, but I found them in different ways. Okay? And then the right side becomes 1 plus 3/2, which is the same as saying 5/2. And I'm purposely leaving it as a fraction at this point. All right, now you solve it by square roots, but since the whole problem wasn't started off by solving by square roots, I don't say that I'm solving by square roots because I had to do this step first. So for this reason, I know I'm using completing the square, and I'm just going to go ahead and write that down here. That was my method. And we did it because it cannot factor. Or it can't be written, what? I don't know what I'm writing. Written as u squared equals d. Okay? All right, but let's go ahead and finish solving this. And I'm going to solve by square rooting both sides, so I get x plus 1 on the left. On the right, I get plus or minus the square root of 5/2. All right. Well, 5/2 is not a perfect square. I'm going to leave it alone for now. But I need to add or subtract 1 to both sides. So I get x is a minus or negative 1 plus or minus the square root of 5/2. Now this answer is correct. But when you go to big ideas, it does not like having a square root in the denominator. Okay? That's called rationalizing. We have to rationalize the number by getting that out. And that is something that had to be done when slide rules and stuff were used. You can't use those with square roots in the denominator. But now we have calculators and we can. The only thing is it's good to remember to know how to rationalize these. So we're going to go ahead and rationalize square root of 5/2. And I'm kind of going to write it over here. Over here. So square root of 5/2 is the same thing as saying square root of 5 over square root of 2. I don't want square root of 2 on the bottom. So to get rid of the square root, I'm going to multiply it by itself, and I have to multiply the top. You can multiply anything by 1, and square root of 2 over square root of 2 is 1. Okay? And when I do that, I get square root of 10, and square root of 2 times square root of 2 is just 2. All right? So I'm going to replace my square root of 5/2 with square root of 10/2. So my final answer is x equals a negative 1 plus or minus the square root of 10/2. All right. Let's move on to number 12. I'm going to have to erase some of this to make room. Okay. And let's figure out what we need to do. So in number 11, see how I had a b? There was an x in the problem, so I had bx, okay? Here, there's no x, so I have a squared plus c, but I don't have a b. So I know I can solve this by square roots. I don't have to do completing the square. So to do that, let's get x squared all by itself. So I'm going to add 20 to both sides. So I have 4x squared equals 20. To get x squared by itself, I divide by 4. X squared equals 5. Whoa, I'm getting a little carried away with my equal sign there. Okay, to solve for x, now we have to square root both sides. So square rooting the left side, I get x. When I square root the right side, I get plus or minus the square root of 5. And that can't simplify anymore. Square root of 5 is a prime, or 5 is a prime number, so there's no perfect square that goes into it, so that is simplified. And so we did this one by square roots. And that was because you can move things around, and it can be written in the form u squared equals d. All right, so now go to the practice. Whoop, I wrote it somewhere. There you go. And do 42, 44, 48, and 49, and move on then to the next video.